robots, but like the eco-friendly kind. Yeah, we're going there today. Get ready to explore the world of robots powered by, wait for it, mushrooms.
It's not as crazy as it sounds. We're talking about a whole new frontier biohybrid robots.
Mm.
Imagine living organisms becoming actual functional parts of machines.
It's like something out of a sci-fi movie. We're actually diving into some cutting-edge research from Cornell University today, all about how scientists are using fungal mycelia, those underground networks of fungi, to get this, control robots.
And it's not just, some random experiment. This research could totally change how we think about robotics, like fundamentally.
Okay, so before we get too far ahead, break it down for us. What makes fungi such prime candidates for, well, building robots? I wouldn't think robot when I see a portobello mushroom.
Well, for starters, think about how finicky animal cells are. They need those perfectly sterile labs, a constant supply of nutrients, fungi, way lower maintenance.
You're telling me, I swear those things could survive a nuclear apocalypse.
Pretty much. They can handle extreme temperatures, acidic environments, even radiation. For biorobotics, that kind of hardiness is pure gold.
So we're treating in delicate cells for the fungal survivors of the world, huh? But how do you even begin to connect, like, a network of mushrooms to a robot arm? Are we talking tiny mushroom muscles here?
Not exactly muscles, but you're in the right ballpark thinking about movement. See, mycelia, they send these electrical signals through their hyphae, kind of like a biological internet, I guess you could say.
Hold on. So beneath our feet, there's a whole network of fungi sending messages back and forth.
Exactly. These signals help them communicate all sorts of things, where the nutrients are, if there are any environmental changes, you name it.
And these researchers, they figured out how to listen in on the fungal conversation.
Exactly. They use these special electrodes to pick up on the fungi's electrical activity, these spikes, called action potentials.
So what, like eavesdropping on the mushroom network? I'm picturing tiny headphones.
Well, you need a slightly more high-tech setup than that.
Okay, so we're picking up on these fungal signals, but how do you go from a spike in electricity to a robot understanding, like turn left?
That's where the robot design comes in. They actually created two different types of robots for this research. One was this starfish-shaped soft robot, and the other was a wheeled robot, like a little robot car.
Okay, so we've got the starfish and the robot car, both taking orders from mushrooms.
Exactly. Now, the starfish robot, it moves using air pressure. Think of it like little inflatable legs. The fungal signals basically control those air valves, making the legs inflate or deflate.
So it's like the fungi are controlling the air supply. Talk about puppeteering skills. And what about the robot car? How'd that work?
So the car, it had little motors and wheels like a normal robot car, but the fungal signals were telling those motors when to move and in what direction.
A self-driving car controlled by, wait for it, mushrooms. I've heard of autopilot, but that's a whole other level. Okay, hold on. I'm dying to know. What do these signals even look like? Is it like Morse code, some secret fungal language?
It's surprisingly complex. We're not talking about just blips on a radar here. These action potentials have a distinct shape, and get this, some of them last for up to 10 seconds.
10 seconds. Isn't that like an eternity in electrical signal time? Our brains send messages in milliseconds.
It's true. Those signals are way slower than what we're used to.
Yeah.
But get this, they're still fast enough to control the robots in real time, which is kind of mind-blowing if you think about it.
So even with those snail mail signals, the robots are still getting the message. This is wild. 10 seconds, huh?
It makes you wonder, if the signals are that much slower, maybe that means they're also, like, way more energy efficient.
That's a great question. And honestly, it's something researchers are definitely looking into. But for this study, it wasn't just about making the robots move. It was about tapping into the fungi's, like, sensory abilities, too.
Oh, right. Like how they find nutrients even when they're hidden underground.
Yeah.
It's crazy how they always seem to know where to go. It's like they have a sixth sense, or in this case, maybe an electrical one.
I mean, we already established they have their own internet down there. So the researchers, they wanted to test if fungi could see?
Well, not exactly see, but they wanted to see how the fungal networks would respond to light, specifically UV light.
UV light. Okay, now that's interesting. Fungi and sunlight, not exactly the most intuitive combo. What'd they find? Did shining a black light on these fungi turn it into a rave?
Not quite a rave, but the results were pretty illuminating. Turns out, they found that the fungi's electrical signals actually changed when they were exposed to the UV light.
Hold on, so the fungi are, like, reacting to the light. They're sensing it.
Exactly. It's like they're saying, hey, Things just got a whole lot brighter in here.
And the robots, what are they doing during this fungal light show?
So they actually used this light sensitivity to control the robots. For example, they were able to make the wheeled robot, the little car, move away from the UV source.
Okay, so the fungi sense the light, freak out a little bit, send a signal to the robot, and it's like, message received, changing course.
That's a pretty spot-on interpretation.
It's like they created a whole sensory system for the robot, all thanks to the fungi. That's amazing. Did they try, like, different types of light?
They did. They tested UV light, blue light, red light, and even white light.
So, like, the whole rainbow.
Pretty
Yeah.
much.
Yeah.
And what they found was that the fungi responded most strongly to the UV and blue light, with the strongest reaction to the UV.
Wow, picky eaters. I mean, light eaters. Okay, I'm getting lost in the metaphor. But this all sounds incredible. I mean, we're talking about robots that can sense light because of fungi. This is wild. But how do you even translate, like, sudden burst of fungal electricity into something a robot can understand? I need more details.
It's a good question. And it wasn't just a matter of plugging the fungi into a robot and calling it a day. They had to develop a whole system for the robots to be able to decode those signals, right? It's like the fungi are speaking their own language,
How?
and someone needed to write a translation guide for the robots.
Did they, like, invent a fungal dictionary or something?
Not a dictionary, but they created this really cool control architecture. It's actually inspired by how our own nervous systems work, specifically something called central pattern generators, or CPGs for short.
CPGs. Okay, I vaguely remember learning about those in college. Remind me, what are they again?
So basically, CPGs are these neural circuits that generate rhythmic patterns of activity, like the signals that control walking or breathing. It's all about creating those repetitive motions.
Okay, so the researchers basically taught the robots to walk and talk in, like, fungal code.
Yeah, you got it. For the soft robot, the starfish one, they translated the signals into these really simple on or off commands for those little air valves that control the legs. But for the wheeled robot, they were actually able to get even more specific, controlling the speed and direction of the robot based on how intense the signals from the fungi were.
That's incredible. We're not talking about just basic movements here. We're talking about nuance. It really makes you realize just how much we can learn from the natural world. This is all incredible, but let's be real. Are we going to see mushroom-powered robots taking over the world anytime soon? Like, should I be worried about my Roomba staging a fungal uprising?
I think we're safe, for now at least. Look, it's super exciting research, no doubt, but we're still in those early stages.
So what's holding us back? Is it like a supply chain issue? Do we need to start growing robots on farms now?
It's not quite that, but you're right. You have to remember, we are working with, like, living organisms here. It's way more complex than just programming a microchip.
Right. Even fungi need their downtime, no telegram sending 24/7. So what's the solution? Are we going to start seeing, like, tiny break rooms for fungi, complete with kombucha on tap?
Probably not kombucha, but you're hitting on a key point. We got to make sure these fungi are happy and thriving if we want them to keep sending those signals. It's all about creating those ideal growing conditions, making sure they've got all the nutrients they need.
And maybe a little vacation time now and then.
Well, we can work on that, but on a more serious note, there are also ways we can actually, like, amplify those fungal signals.
Amplify. So, like, turn up the volume on those electrical whispers.
Exactly. Genetic modification could be a game changer here. Imagine being able to tweak their DNA, making those signals louder and clearer for the robots to pick up.
Okay, now you're talking. Fungal modifications. Robots that can see. This is some serious sci-fi stuff. But let's bring it back down to Earth for a second. Besides freaking out my Roomba, what are some of the real-world applications for this technology?
Oh, the possibilities are huge. Think about agriculture, for instance. Imagine robots with these fungal sensors going out into the fields, monitoring crops.
Like little mushroom-powered farmhands. I can dig it.
Exactly. They could detect subtle changes in the soil, identify plant diseases, way before we'd ever be able to see them with the naked eye.
It's like giving farmers a superpower. That's pretty amazing when you think about it.
And that's just the beginning. Think about, like, disaster zones, places where it's too dangerous to send humans, or even, like, other planets.
Whoa, hold on. So you're saying we could send these mushroom robots to, like, explore Mars? Sign me up. I always knew fungi were out of this world.
Well, it's definitely within the realm of possibility. These biohybrid robots, with their fungal sidekicks, could be our eyes and ears in these extreme environments. But, there was one detail from this research that I found particularly fascinating. Remember how we talked about the fungal signals changing over time, almost like they were learning?
Oh, yeah, that was mind-blowing. Do you think we could actually, like, teach those fungal networks?
It's a huge question, and honestly, one we don't have the answer to yet, but it opens up some really exciting possibilities.
Imagine that. Training fungi, like programming living organisms. This is some next level stuff. Who knows, maybe one day we'll all be using biocomputers powered by mushrooms.
Stranger things have happened.
That's for sure. Well, I think we've given our listeners a lot to think about today. Mushrooms controlling robots. The future is officially weird, and I'm here for it. Thanks for joining us for another deep dive. And remember, keep exploring, keep asking questions, and most importantly, don't underestimate the power of fungi. You never know where those fascinating organisms might lead us.